Similarity proofs. How can you organize deductive reasoning of a geometric proof? Right. What are we trying to do today? We're going to try and write a two-column proof. We're also going to try and prove the geometric theorem, prove geometric theorems by using deductive reasoning. I told you today was a day that will change your life. It's a day that will move an infamy. It's a day that when you're 98 years old, you're going to talk to your little great grandkids about. Okay. This is the day that your head officially exploded. All right. When writing a proof, don't write this down. Don't worry about writing it down. It's okay. Just read it and listen. When writing a proof, it is important to justify each logical step with a reason. Y'all know how sometimes y'all ask me why? Yeah, why? Why? Now it's my turn to ask all of you. Why? Why? Because of hypothesis. Okay? No, we start with a hypothesis. And then we get to this part, which is where we write our proof. That's why you start. All right. You can use symbols and abbreviations. They must be clear enough so that anyone who reads your proof will understand them. That would be me. So I'll tell you what symbols you can use, not use abbreviations and all that good stuff. Okay? All right. So here's what's going to happen. We're going to have a hypothesis. You're going to have a little bit of given information. You're going to take that information. You're going to use definitions, postulates, properties, or theorems that we talked about to reach your conclusion. You're going to do it step by step. All right. It sounds okay. A couple things that you're going to want to write down. I will try and enlarge them so that people in the back can read them. A theorem is any statement that you can prove. That's simple enough, right? Any statement that you can prove is what we call a theorem. Once you have proven a theorem, you can use it as a reason in later proofs. Okay? I've got the linear pair theorem here. Two angles form a linear pair. They're supplementary. Right? Again, I'll go back to transversals. All these will become easier once we get to transversals, but we're going to do these. I've also got the congruent supplements theorem up here. If two angles are supplementary to the same angle, or to two congruent angles, then two angles are congruent. Okay. Somewhat like our transitive property that we talked about yesterday. 1 and 2 are supplementary. 2 and 3 are supplementary. We don't know what supplementary means yet, but what we would conclude from that is that 1 and 3 are congruent. Supplementary, just to give you a let get out of that. Supplementary means two angles add up to be 180 degrees. Complementary means angles add up to be 90 degrees. Supplementary is 180. Complementary is 90. There will be a quiz on that. It's not a quiz I just made this morning. Yeah, I see. Okay. No, it's okay. Those are the year-long ones. Yep. Like the first day after I was in year-long. Okay. All right, a couple more seconds on this guy. You need to write linear pair theorem and congruent supplements theorem. I'm moving on. What? Okay. 3, 2, 1. I'll come back to it. Okay. Sorry, right there. The geometric proof begins with a given and proof statements. No, don't write this. Just listen. Read it and listen. DJ, all of these are posted there. Every slide. Okay? It's posted in a video form, not a slide. Okay? All right. Proof begins with a given. You're going to have a given statement. Given angle 1 and angle 2 are congruent. Given angle 3 is 58 degrees. Given line segment RS is 8. Okay, with a given statement, you have to start somewhere. And you're going to be prove. It's going to say prove blah blah blah. That's what you're trying to do at the very end. Prove. End goal. What am I trying to prove? Okay. It's going to restate the hypothesis, conclusion of the conjecture in a 2-column proof, which is what we're going to be writing today. You list the steps of the proof in the left column, you write the matching reasons for each step in the right column. Here is an example. Okay, here's an example. This is the simplest example we'll do all year. Fill in the blanks to complete the 2-column proof. Given x, y, what does that mean? Prove that xy is congruent to xy. Start there. Okay. Nope. Xy should be a line segment. Okay. I've been given that I have a line segment xy. I know by the reflexive property of equality that we talked about yesterday that xy is congruent to itself. Okay. Just talked about that. Xy is congruent to itself. Therefore, xy is congruent to line segment xy is congruent to line segment xy because of the definition of congruent segment. Okay? Right? This is the flow. I don't want you to think about memorizing anything. It's not a memorization type thing yet. Okay? It's just a flow. Notice where you start. Every time you're going to start with a given statement. Okay? And you're going to work from there to prove your particular theorem. Okay? Here's another one. Let's fill in the blanks to complete the 2-column proof. One case of congruent supplements theorem. I've been given angle 1 and 2 are supplementary, and angle 2 and 3 are supplementary. Okay? That's my given statement to you. I want you to prove that 1 is congruent to 3. Notice how this flows. Okay, y'all see this? See how it flows? Your statements are on the left, and your reasons are on the right. Statements are on the left, reasons are on the right. Right? First, I will start with what? My given information. My given information was that angle 1 and 2 are supplementary, and angle 2 and 3 are supplementary. Then I say the definition of supplementary is that angle 1 plus angle 2 equals 180. The definition of supplementary is that angle 2 plus angle 3 is 180. Okay? What happens next is you use the substitution property to say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. What do we do from there? Well, from there we could say you can do algebraic proofs or you can do geometric proofs. You say measure of angle 2 equals itself on both sides of that equation. It would cancel itself out. Okay? This particular statement right here is because I am canceling out those two particular angles, right? Right? And if I cancel those out, what's left over? Right here. Measure of angle 1 equals the measure of angle 3 for my substitution property. And then finally, if they're equal, they're congruent because of the definition of congruent angles. going to be doing stuff like this, trying to write two-column proofs. Given that 1 and 2 are supplementary, and that 1 is congruent to 3, I'm trying to prove that 3 and 2 are supplementary. Okay? How would I start? Yes, sir. It's a good question. I'm going to give you the cheating answer, which is that we'll never ask you something that you can't prove. Okay. All right. I'm sure in higher levels of mathematics, I'll have a better answer than that. All right. Some of you will move on. You'll take non-Euclidean geometry maybe one day, or Euclidean geometry. I don't know. Whichever one you take when you go get your math degree, and they'll talk to you about how to write proofs when you don't get to the final proof. Okay. Yes. Not, they could be, but not. No, if they're they can't be supplementary and complementary at the same time. All right. Again, I'm gonna ask my question again. Where do I start every proof? You gotta learn something. Where do I start every proof? Thank you. I start every proof with what I'm given. Okay. I'll start this proof off by saying angle 1, angle 2 are supplementary, angle 1 is congruent to angle 3. How did I get that information? Right there in the given. Okay? Your EOC, when they ask you these types of questions, I would look right there to the given to begin with. Write something down. Okay? Exactly where you should start. Right? What am I trying to prove here? Well, very good. Okay. Tells me prove the 3 and 2 are supplementary. It says this is a plan. How am I going to do that? I'm going to use the definitions of supplementary and congruent angles and substitution to show that the measure of angle 3 plus measure of angle 2 equals 180 degrees. By the definition of supplementary angles, 3 and 2 are supplementary. Okay. Look what they do. We start with our given. 1 and 2 are supplementary. What does that mean? What does that mean? That means, go ahead. It means that added together, they equal 180. Okay? See how we flow from my given information to the next statement. Y'all see that? Right? Okay. This is where I'm talking to you about like the whole deal about why. What's the big deal? 1 and 2 are supplementary. So what? What does that mean? That means that the measure of 1 plus the measure of 2 equals 180 degrees. Great. Thanks for letting me know that. Okay. Now what's the next part that I can do from there? Take my other bit of given information, say angle 1 is congruent to angle 3. That's great. What the heck does that mean? That means that the measure of angle 1 is equal to the measure of angle 3. How do I know? My definition of congruent angles. Okay? That's where we're going so far. Well, you'll see where this is going. If 1 plus 2 is 180 and 1 equals 3, I can substitute 3 in for 1. I can substitute the measure of angle 3 into the measure of angle 1 and include it into my original statement up here, right? All that happened. I took what I knew about 3, what I knew about 1, they're equal to each other. I substituted them, right? Okay. After I substitute them, I get this statement right here. 3 plus 2 is 180. If 3 plus 2 is 180, what does that mean? That means that 3 and 2 are supplementary. Finally, I've gotten what I was looking for the whole time. Last one. This is it. Write a justification for each step. I want y'all, this is the interactive part of the lesson. Okay, so y'all gonna help me out with this. Okay, given that the measure of ABC is 90 degrees and the measure of angle 1 equals 4m 4 times the measure of angle 2. Okay, 4 times the measure of angle 2. Right? Help me out here. My statement is measure of angle ABC is 90 degrees and the measure of angle 1 is 4 times the measure of angle 2. How do I know that? Thank you. Now we're catching on. Okay, this is given. Right? The measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Very first day of class. We did the very first day of class. Angle, what about angle? Yep. If I have angle ABC, the big angle, I can take the measure of angle 1 and add it to the measure of angle 2 to get the big angle measurement, right? Call that the angle addition postulate. Angle addition postulate. Okay? With me so far? Right? Now, this is where after these 2 steps, I think if I told you this was a word bank, y'all might have gotten that one, okay? This third step's the tough one. How am I able to jump from 1 plus 2 equals ABC to 4 times the measure of angle 2 plus the measure of angle 2 equals 90? Okay, I use this given information and I substitute it in. Okay, I can use substitution. Tell me that. If 1 plus 2 equals 100, equals ABC, and ABC equals 90, that means that angle 1 plus angle 2 equals 90. But notice I didn't call this angle 1, I called it 4 times the measure of angle 2. Okay? All of that was my given information. Right? I then, and I don't know what they want us to call this stuff other than combining like terms. Okay? If I have 4 times the measure of angle 2 plus 1 times the measure of angle 2, that would give me 5 times the measure of angle 2. I'm not worried about that one. Okay? I just want to know what I call that CLP, combine like terms. Okay? I just want you to get through that step. And then finally over here, of course, I would divide both sides by 5. The measure of angle 2 would be 18 degrees, correct? And I would call that simplified. Right? Let's see how I did. Pretty good. Look, they simplified here and divided down there. Okay? All right? That's pretty clear. Okay? Okay. Cut this off.